Welcome, everybody. So let's see some AI in action. So every time you order something on Amazon, likely a robot helps to bring it to your door. There are hundreds of robots working in the warehouses almost 24/7. If you walk into a modern car facility, you see robots skillfully assembling your car with precision and speed. But also at night at IKEA, you see flying robots checking the inventory in the different aisles. So robotics has really provided and delivered proven impact already. But what we are going to see in the future is far beyond what we have seen up to today. With AI, robots can learn in parallel, they can reason about their environment, and they can imitate what they see in videos. And so what we are going to see is an unstoppable transformation led through AI that really translates into the physical world. And this will provide huge opportunities for research, for industry, but also for society. And this is the reason why my talk is called AI-powered robotics is changing the world, and the time to lead is now. I showed you with a few examples at the beginning of the talk that robots are here, and they are going to stay, and we will see more of them. Amazon just deployed their 1 millionth robot in their warehouses, and soon robots will outnumber the humans in their warehouses. In other news, DHL committed to deploy 1,000 more robots as part of their 1 billion automation strategy in their logistics facilities. And self-driving is here. We have Waymo completed more than 50 million miles driving in a completely self-driving mode, and they do this very safely with significant decreases in property damage claims and bodily injuries. But most of these robots are still largely programmed manually. And this works well in structured environment. There, robots outperform humans today, but they really struggle in environments where complexity and unpredictability is present, like our homes, our roads, our offices. But machine learning is here to help, but we do need the right data. And so in my research, we have for a long time used robot-specific data to improve performance. And this is just a little example to show you what that means. So from a few minutes of flight data, we can improve the flight performance on arbitrary hand-drawn trajectories by 50 to 60%. But this type of research, that will not get us to general reasoning and intelligence capabilities in physical systems and robotics. So we need something more. And this is the transformation I'm talking about. We are going from an age of automation where robots can work in structured environments based on our prior knowledge to an age of autonomy where robots leverage robot-specific data, and a very good example is self-driving, where companies have spent huge amounts of money to collect robot-specific data on driving on the road to help robots understand the road environment. But those robots know nothing about offices, about hospitals, about our homes. And so the next stage, and that is really the transformation, is to go to an age of intelligence where we leverage internet-scale knowledge in physical systems. And that can be language understanding. A lot of information about how the world works is described in language on the internet. It can be image understanding, video understanding, and beyond. And so today, as a first step, I want to show you a few examples what that may mean from my lab. So one is about using AI for safe robot crowd navigation. And so here we leverage large-scale human crowd navigation crowd videos to learn how humans behave in crowds, and then leverage that information to enable a robot to safely and effectively go to its goal location through a crowd of humans. And robots are physical systems, so we really have to care about the safety, and so we have a safety filter implied that guarantees collision-free motion on top of this. And so here's an example, and the core novelty is the robot understands how its own actions influence how the human reacts. And so here you see on the left a top-down view where we have a machine learning model, a diffusion model to predict the human motions. And on the top right, you see how the robot detects the humans and then drives around them, but sometimes it may also push the human away because it knows the humans generally back up if it comes too close. So this is a way where we use standard crowd data to enable a robot to understand how humans move in crowds. But we can go beyond this. We can leverage the information that is embedded in language models and translate them to the real world of a robot, such that it can query what it can do safely in the scene it sees. So for example, we know that a full cup of coffee or water, it may not be a good idea to move this above your laptop. And so that information is embedded in a lot of data, text data in the internet, and that is what we use to enable a robot to reason about its environment. So how this works is the robot may be teleoperated or operated in an autonomous mode through any policy, and then we leverage language models and open vocabulary segmentation to understand what a robot can safely do in its environment. And the important thing is neither the understanding of the environment nor the querying of the language model are specifically trained with data from the robot. This is really internet scale knowledge that we have at our fingertips, right, basically for free. And so here is just a few examples to show you what this can do. So on the right, you see how this semantic safety filter holds the robot back of doing something unsafe. So here on the right, it holds the robot back of putting a bottle on top of X, for example, because it can understand what it sees and it can query a language model if the actions it's about to do are actually safe. A metal bottle on a stove may be not a good idea because the stove may be hot. Or putting a fork into a power outlet, also not a good idea. And it can connect what it sees with the language in a language model and then avoid this unsafe behavior. But something that is really fun and close to my heart, because I spent weeks and months and years to program swarms of robots to navigate safely in an indoor environment, is that we now use AI to program safety-critical robotics applications, namely swarms of drones. And the idea here is that a non-expert can provide music and an initial prompt about what it wants the swarm of drones to do, and there's a vanilla language model that translates these ideas into waypoints for every drone in the swarm. But, and that is important, these language models do not know anything about the physical reality. They do not understand the capabilities of the robot, the size of the robot, etc. And so then we move this into a safety filter, which is an innovation on its own, to generate something that the drone swarm can do safely. And this is one of the results. And we have experimented a lot also with reprompting, and you can reprompt with natural language. Here's just a very obvious example to show you where we on the right did a reprompt and said, please use fewer circles in the performance. And just in natural language, talked to the swarm of drones. And we can generate these in minutes for up to 200 drones. And the last example I want to show you is to show that we need to ground information that we have in the environment to the robot's reality and sensors. So here the robot understands what it sees in a completely unknown room. It understands what object it sees, and it tries to find classes in this case. And so it uses and leverages relationships of objects. For example, that classes are rather seen on the top of a table instead of the kitchen counter. So it basically translates relationships from language into physical reality. So these were just a few examples from my research lab where we leveraged internet-scale knowledge that's now at our fingertips that are basically for free. We do not have to collect extra data in robotics. But there's, of course, a lot of fundamental research still to do. You saw in all these examples, we have to translate language, image understanding to the physical reality of the robot. We may need more data still because videos do not capture what we feel if we do fine manipulation tasks with the robot. And we want robots usually to perform better than what we do. And so imitating just us may not be good enough in the long term. Nevertheless, just a few examples I showed you were done by my small research lab in a few months. So we are really at an inflection point where we go beyond the exponential growth that we have seen in industrial robotics to a predicted robotics market that quadruples in the next 10 years. And examples that I haven't showed in detail, but we saw it in Aline Albushev's talk today in the morning or afternoon, is that humanoids are predicted to grow by a factor of 100 over a decade. And there are crazy numbers right now from huge funding rounds of over 300 million to predictions that we see in the next 10 years, millions of humanoid robots being deployed. So there's a real inflection point, leveraging AI to make robots more capable. And here in Munich, we are in a good position to lead in this field. We are excellent in academia. We heard it in the morning. We are usually in the top 3 worldwide. We have over 1,000 PhDs and postdocs working in this field in the Munich area. There's a few first steps in terms of startups, and we also have taken a leadership role on the national level, where Germany has started the Robotics Institute Germany, which has the goal of being a national network with a global impact in AI-powered robotics, really nationally binding or bringing together the strengths. And I really invite you to see as we progress with this effort. So to conclude, robotics has had a broad impact. It's not, nobody denies that robotics has changed the world already, but we are at the cusp of a real transformation due to AI. And to lead, we really need to join forces, industry, researchers, and policymakers to make a difference. And I call you to action now here at the last talk to join us to shape the future of how robotics and embodied AI will look like. So together we can really change and shape how robots will change the world. Thank you.